Hello. So, Hello. so we are going to study engineering mathematics today, and this is the book we are going to refer. Let me just connect my mouth. So this is the book. What- Okay. So this book is Fundamentals of Mathematics Statistics by S.C. Gupta and V.K. Kapoor. And this is an Indian book. We are going to start with the chapter 7, that is, you can see in the index. It is theoretical discrete distributions, and we are going to go through all these topics you can see here, including the binomial distribution, starting with that, and then Poisson, and ending with the recurrence moment, the MGF. Okay, so let's start. The page number is 453. This is actually from the seventh, no, sixth semester, but in some colleges it can be in fifth or fourth, even third. So it depends what is the semester and college. So let's start with this topic. Here we have the first uh, introduction. We got the definition, binomial distribution, a random variable, एक ऐसा वेरिएबल x जहाँ पे उसके दो वैल्यूज हो सकते हैं 0 and 1. Yes, we know that. And the probability of getting 0 and 1 can be q and p, not p and q. So it can be interchangeable. For example, इसने पहले q लिया है then p, so इसका हो गया x के वैल्यू 1 आने की probability p, then x की 0 आने की q. And this is Bernoulli variate. Going through, we have the moments of Bernoulli distribution. We will solve questions and then understand these topics. And this is the definition, the history behind the Bernoulli distribution given by James Bernoulli. Okay. Well, let's see this topic. The definition: a random variable x is said to follow binomial distribution if it assumes only negative values and its probability mass function is given by this formula. So, okay, let's actually start with the question. Assignment of probabilities is permissible because, okay, these are just proofs. So, this is the first example given here. Let's try to solve this. Example 7.1. That is, we have, let's just put question here. So 10 coins are thrown. The given number of coins is 10. And then find the probability of getting at least 7. So out of these 10, we have to find the probability of getting 7 what? 7 heads. Okay. So the solution is the solution starts with taking the two different probabilities, that is P and Q. P being the probability of getting head. So let me just put it here. And the Q is the probability of getting tails. Both are equal. That is half 1/2. The probability of getting X heads in a random throw of 10 coins. Like if you throw 10 coin एक साथ फेंक दिए तो उसमें एक में आने का प्रोबेबिलिटी हाफ है ना, तो 10 में आने का क्या प्रोबेबिलिटी होगी वो यहाँ पे गिवन है, दैट इज पी एक्स 10 एक्स half to the power of x and half to the power of 10 minus x. तो सबसे पहले हुआ क्या, इसकी फंक्शन आ गई 10 और x की। इसको हम रिप्रेजेंट, आपको पता ही होगा, इसको रिप्रेजेंट कर सकते हैं 10 फैक्टोरियल x फैक्टोरियल 10 minus x factorial. Okay. Let me just pull up the note. So it's 10 factorial x factorial 10 minus x factorial with the power half with the power of x and half being the tails being the power 10 minus x. So it equals down to 10 n x half to the power of 10, and the x and minus x powers are cancelled out. So these are the value, and x starts from 0 to 10. X was getting heads, so we can get 0 heads, we can get also 10 heads, and we can also get the heads between the range. So, moving forward, sorry for the delay. We got to solve this p of x, as the addition from 0 to 10. But in the question, it is given that we have to find the probability of getting at least 7. So, at least 7 includes getting 7, getting 8, getting 9, and getting 10. So, probability of x, that is, probability of getting head, should be probability of x then greater than 7. So, it includes the probability of getting head being 7, being 8, being 9, and being 10. And this formula is applied accordingly, in to each of these. Let's go through that. So it will be, and the x changes. X will be 7, 8, 9, and 10 uh, simultaneously. So it will be like 10, 7 into half to the power of what? The x and minus x will always cancel out. 7 minus 7, 8 minus 8, 9 minus 9, and here 10 minus. So it will eventually will be like this only. So to the power of 10 plus 10, 8 to the power 10, half to the power of 10 to till here. So let me just bring up some notes section. हम्म। क्या हुआ सर? पानी तो मंगा लिया ना। So basically, the formula becomes, you know, P of X. Wait, just wait. So the P of X becomes the probability of getting 7x and to here till getting 10x. Okay. And if we break down, it will become 10 by x. So instead of writing x here, we will replace this by it's 10, 7, then multiplying with half to the power of 10. And where is the expansion? Okay. And then adding it with the same thing 10, 8, half, and to the power of 10 till this 8 becomes 10. So 8, 9, 10. And okay, how can you write like what is this 10 and 7? So it is 10 factorial divided by 7 factorial multiplied by 10 minus 7. So it is 3 factorial. Okay. So going back to this, it will become, we will take the half to the power 10 common and add 10 7, 10 8, 10 9, and 10 10. So there it is. So let's see. It will become 10 factorial as the numerator of all of that, and divided by 7 we have already wrote. What is this highlighted and okay, nice. And here it will become 8 factorial and 10 raised to 8 is 2 factorial and 10 9 and 1. 10, 10 and 0. So you can take 10 factorial as common or cancel out separately. So this will become 10 into 9 into 8 and so on. So it will result into giving you this expression. And for this, what do we have extra? Yeah, we can put on this one. Switching to this. Yeah, switching to this. So on doing the calculations, we would find the half to the power of 10 is, let me bring out scientific calculator. So I've got my scientific calculator and upon calculating everything, it is 10, 7, 3, and 10, 8 factorial, 2 factorial, 10, 9 factorial. What is 0 factorial? And then 10 factorial, 10 factorial, 0 factorial, it cancels out, so it gives us 1. And here we have 10 into 9 into 8 upon 3 into 2. So 4, 3, 120. Yeah, it's confirmed. The next one gives us 10 into 9 into 8 factorial and 8 factorial into 2 factorial, that is basically 2, and 8 factorial cuts out. 2 gives us 5 into 9, that is 45. 10 factorial into 9, sorry, 10 into 9 factorial, 9 factorial cancels out, gives us 1, 110, and then 1. 120 plus 45 plus 10 plus 1 divided by 1024 because half to the power of 10 is the reciprocal of 2 to the power of 10, that is 1024. So it comes in denominator. So it is 176 by 1024. Yeah, it's correct. The answer is correct. Moving on to the second question. This was one of the easiest ones. Second question is, okay, let me switch up this. And here we are on the second question. A and B play games, okay, and the chances of winning is 3 is to 2. So if, out of 5 games, A wins 3 and B wins 2. What is happening? Hmm. Find A's chance of, find the first person chances or chance of winning Why am I not getting the Adobe? Like, hmm, now it's good. Of winning at least 3 games out of the 5 games played. And this is from Burdwin University based on a 1993 question. Winning at least 3 games out of 5. Okay. Mhm. What is the solution given? That is P with the probability of A. It is taking the probability of winning of A as P, and otherwise B will be Q, obviously. And it is 3 by 5 from the question, and it is 2 by 5. Binomial probability law states that the out of 5 games, A wins R, and here it is. Okay. So P of X, that is R. So basically P of R is 5R. It can be 3, 1, 2, 5 out of 5, anything. And it is asking, since it is asking at least 3, you can see here, it is asking at least, yeah, at least 3. So we will neglect the winning of 1 game out of 5 and 2 games out of 5. So it will become 5R, 3 out of 5. So 3 by 5, the power of R, 2 by 5 to the power of 5 minus R. Okay, this 2 by 5 is out of the person B. And now R can be 0, 1, 2, 3, 4, and 5. The required probability of A of winning at least 3 will be similar like the last question, 5R and 3 by 5. Okay, this will, in this question, it's not half and half, so the x and x will not cancel. The R and minus R will not cancel out. It will be there. So we have to put T by 5, R as 0, 1, 2, and okay. And 2 by 5 is the power 5 minus 0, 5. And the summation is just from 0 to 5. So we can also not include the summation symbol here. And it will become, let's, we can take the 5R as common or what? What's given here? Uh, in the denominator, it is taking the denominator as common because it will always be 5 to the power of 5. For example, 5R 3 by 5 to the power of 0 is 1. So 1 into 2 to the power of 5 plus 5R. Let's take the 5R common here. And then we get 3 by 5 to the power of 1 and 2 by 5 to the power of 4. So the denominator 5 will always be 5 to the power 1 and 5 to the power 4. It will always be 5 to the power of 5. So what it does is 5. And okay, the R also changes. So 5, 3. Here it will be 5, 4. So I am on the way. So it will be 5 factorial, 3 factorial, 2 factorial into 2 by 5 to the power. What we can do is take the denominator 5 to the power 5 common. Okay. The solution also does that. Has taken 3 to the power of 3 common, because in the first term it's not there. Okay, okay, okay. Okay, then it add-ons nothing. Oh, okay, okay. I was considering from 0 to 5. See, that's the problem. मैं क्वेश्चन पढ़ा और 3 से ज्यादा कह रहा था ना, so we will not consider 0, 1 and 2. Why was I considering them? So ये तो छोटा सा क्वेश्चन हो गया, 3 से बड़ा. अब ये बन गया हमारा 5t and 3 by 5 to the power of 3, 2 by 5 to the power of 2 plus 5, 4, 3 to the power of 4 to the 2 by 5 to the power of 1. And 5, 5. So 5, 3 will be 5 factorial, 3 factorial, 2 factorial. It will cancel out into 5 into 4, 20 by 2 factorial. It will be 2 into 10. So this is 10. We will take the 5 to the power of 5 denominator as common. 3 cube is here, 3 cube is here, and here it will be 3 by 5 to the power of 5, 2 by 5 to the power of what? 0? Yeah, 0. So it will become 1. So we can also take 3 to the power 3 cube as common. Yes, the solution was correct. So it will be 10 into 2 square plus 5 factorial by 4 factorial by 1 factorial. It will be 5. So 5 into what? 3? 3 into 2? 3, 2, 5 times 6. Plus we have also got what here? 1 into what is this? 3 square. So this is 40 plus 30 plus 9. 79 is the answer. And dividing it, multiplying it with 3 cube by 5 to the power of 5 into 79. So let me check up with the scientific calculator. 27 into 79, 2133, and 5 to the power of 5 is 315. Divide it. I think it's pretty accurate. The answer is correct. I think 0.62, sorry, 0.68256, 0.68. We are getting it. Yeah. So the second example is also solved. Moving on to the third one. If m things are distributing among A men and B women, for example, there are golden coins, m golden coins, we have to distribute it between A and B. A are the group of men and B are the group of women. Show that the probability that the number of things received by men is odd. So the MA is odd, and anything else? Acha, is given. So M is given as half B plus A to the power of M. B minus A to the power of M divided by B plus A to the power of M. Let's see how that. Okay, something is given. Long solution. The solution is given as the probability of things received by men is what they received plus what is the whole number of things, that is m. So a by m, or we can say, no, wait a minute. Yeah, it is a by m, and a by a plus b. A plus b are the number of men and women together. So number of participants, and a the number of men. And women will get b out of a plus b. The probability of the probability is exactly x are received by men and the rest by women. So it is taking one moment at a time. So P of X, मतलब M, let's say 100 coins थे, उसमें से is taking 80 coins or 70, any of that as X. So P of X is given as MCX, PX, Q, M minus X. This is what you say, where X is 0, 1, 2, 2 till M. We don't know the limit M. Okay. How can we represent MC in probability? So what it has done is it adds up the probability of x being 1 till m. So it will be p1, p3, p5. So mc1. So it is m1 in the but we have already seen. Q start with m minus 1. Writing q before the p, and then slowly it decreases. P, the power of p increases. What had done here? Okay. Qm is there, minus 1, mc1. This whole term is here, then mc2 is here. What is this then? This is the probability of getting the whole. Okay, all the probabilities. And this is minus, 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 just replacing it, the alternative terms with minus. Yep. So adding these two equations is twice of something something. Okay, these are the first term, the third term, and the even terms. I think they cancel out. These should be canceling out now. Okay, we are minusing, we are subtracting the, so these signs will change, these will cancel out, these will add, and these even terms will cancel out. So we get the odd terms only, and it is twice of p. Why? Because they are twice of this, and this is p, the probability of getting to x. Wait a minute. Is it? Why is it writing P here if we are getting 1 plus? Okay. 1 plus 3 plus 5 is this, and it is showing that if we can get this Q plus M, Q minus M, and then we can achieve this. So this is P from here, the men probability. So it's 2P. And adding these will be Q to the power of, and opening M will be like, we know it's 1 only. So this will become 1. And it will only want to say, people say, how? Mm, okay. So 1 minus this whole power M is equals to 2P, and we can replace the substitute or everything on one side. So we will get P as this. Okay. So we are ending this game on this. We'll start with the next example.